Today in section 4.5, we are going to convert from standard to vertex form by completing the square. When we do this, we're going to look for and make use of structure. Once again, we're going to be using the structure of equations to be able to convert them from the standard form to the vertex form. So let's just kind of refresh our memories a little bit. Standard form of quadratics is y or f of x equals ax squared plus bx plus c. And then the vertex form is that y or f of x equals a times the quantity x minus h squared plus k. So we are going to have numbers in the a, b, and c spots in the standard form, and the a, h, and k spots on the vertex form. So thinking back, going from vertex to standard form, our steps that we go through are first, we double distribute. We double distribute a binomial that was a perfect square. So for example, that first step, we had something like x plus 3 squared, and we double distributed. So we wrote it as x plus 3 times x plus 3. And so it became x squared plus 3x plus 3x plus 9, which is x squared plus 6x plus 9. Well, do you notice something about this? This was a shortcut that you might have noticed in every single one. If you take this number and double it, you get the b value. And if you took that number and doubled it and squared it, you got the c value. And so that would be a shortcut, so you don't have to go through these middle two steps every time. So let's go ahead and write that with variables. So if we use x minus h squared, just because that is vertex form, the a is 1, the b is negative h times 2, or you can just say 2h, and then the c is negative h squared, or if you just want to think of it as h squared. So we multiply it by 2, and we square it for the b and the c. If you think way back to Unit 3, when we were factoring and we learned the shortcuts, there was one that we didn't focus a whole lot on, but that's what we're going to use today. It's the one that is called a perfect square trinomial. So remember, that is when you have x squared plus 2ax, so this would be twice times a number, plus a squared, so this is a number squared. That's going to be equal to x plus that number squared. So that number is right there. This is what we are going to be using today. We're going to use this to do what is called completing the square. So we're going to use a perfect square trinomial to complete the square to convert from standard to vertex form. So the first part of this is we're going to convert from standard to vertex form when a equals 1. So let's go ahead and go through the steps and work it out for this problem right here. So what I first need to notice is that this C value is not a perfect square. So right away, I know that this is not a perfect square trinomial. So my first step is going to be to move the C value. So over here, if I want to move 10 to the other side of the equation, I'm going to do the opposite operation, so I'm going to subtract it. When I do that, I get y minus 10 is equal to x squared minus 6x. That's my first step. That's all I need to do. My second step, and this is the new part, this is what can be kind of tricky, is you need to find a new C value that completes the square. So find a new C value that completes the square, meaning it completes that perfect square trinomial. Creates a perfect square trinomial. So if we're looking back up at our perfect square trinomials, right now I have this part of the trinomial, and I need to figure out what this is. So to do that, I'm going to take the b value divided by 2, and then to get that, I need to square it. So over here, I'm going to take the b value, which is negative 6. I'm going to divide it by 2 to get negative 3. And then in order to get the c value then, I need to square that. So I need to take negative 3 squared, which is positive 9. So I want to write that at the end to complete the perfect square trinomial. So I have x squared minus 6x plus 9. So I added this last part. If I add 9 to the right side of this equation, then that means I need to add 9 to the left side as well. So the second step is to figure out what this number is and then to add it to both sides. So a reminder, whatever you do to one side, you must do to the other side of the equation. All right, my next step, I need to write this as a squared expression. So this is going to get that binomial that I need in order for it to be in vertex form. So I'm going to take x squared minus 6x plus 9, and I'm going to write that as a binomial. So if I look back up to what a perfect square trinomial is, right now I have the trinomial, but I want to write the binomial. So I'm going to take the a value, and I'm going to just plug it in right there. So the a value is going to be this number right here. I can also look at the b and divide that by 2. So it's negative 3. So the squared expression is x minus 3 squared. And then on the left side of this, I have y minus 1, because negative 10 plus 9. I combine that to get negative 1. So right now I have y minus 1 equals the quantity x minus 3 squared. Now my last step is to isolate the y term. So I just need to add 1 to both sides to get that y term, the y side by itself. So y equals the quantity x minus 3 squared plus 1. Now if I think about vertex form, it's y equals a times the quantity x minus h squared plus k. Well, this is in that form because this is when a equals 1. So if a equals 1, I don't even need to write it. So my numbers are all matching up, which means that this is in vertex form. We're going to go through this same process on every problem that we do. And so this equation right here is the exact same as that one. They're just written differently. All right, let's go ahead and do the next one. Try that one on your own. If you are struggling with this, then you can go ahead and play this. I will talk through it. If you're feeling kind of confident, pause the video and work through it, and then play it to check that your understanding is correct. So my first step when I do this is I need to move the c value. So I'm going to subtract 5 from both sides. So I have y minus 5 equals x squared minus 12x. My next step is to complete the square. So that means I need to take this value, that negative 12, divide it by 2, which is negative 6, and then I need to square that to figure out what that c value is. So I'm going to add 36 to both sides. I cannot forget to add it to both sides. So y minus 5 plus 36 equals x squared minus 12x plus 36. Now my next step is to write this as a squared expression, so I need to write that binomial. The left side of this I can go ahead and simplify to y plus 31. Now the right, I need to take this perfect square trinomial and write it into that binomial that's squared so that it is in vertex form. I'm going to do that by using this number right here. So this becomes x minus 6 squared. And then finally, my last step is to isolate the y. So I'm going to subtract 31 from both sides. And I have y is equal to x minus 6 squared minus 31. And that is my final answer. That is written in vertex form. All right, let's do another one together. Y equals x squared plus x minus 31. So once again, my first step is to add that c value to the other side. Make sure you're being very careful of your signs when you do this. So I have y plus 31 is equal to x squared plus x. My next step is to complete the square. So I need to find that c value. To do that, I'm going to take my b value, which is 1, and divide it by 2. And that's just going to be 1/2. And then I'm going to take 1/2 and I'm going to square that to get 1/4. So I need to add 1/4 to both sides. So y plus 31 plus 1/4 is equal to x squared plus x plus 1/4. So now I'm going to simplify this on the left side, and I'm going to write it as a squared expression as that binomial on the right side. So I have y plus 31 1/4 is equal to x plus, I'm using this number right here, so x plus 1/2 squared. And then lastly, I need to subtract that 31 and a fourth from both sides. So I have y equals x plus 1/2 squared minus 31 and a fourth. Now, there's fractions in here, and that kind of makes me wonder if I did this correctly. So if I would like to check this, we know how to go from vertex form to standard form. So what we can do is go from vertex to standard form. So I'm just going to write this over to the side, and I'm going to go through that process. So y equals the quantity x plus 1/2 squared minus 31 and a fourth. And I'm going to just go through that process of vertex to standard. So the first thing I need to do is double distribute. So I have x plus 1/2 times x plus 1/2, which is x squared plus 1/2 x plus 1/2 x plus 1/4. And then I'm going to simplify that. So y is equal to x squared plus x, 1/2 plus 1/2 is 1, plus 1/4 minus 3 3/4 is actually going to be a negative 31. So that is in standard form. So now I can see that I ended up getting the same numbers there. So that is how you can check if you're not sure of your work. I'm just going to move this over here to the side. All right, go ahead and pause the video again, and you're just going to complete the square here. So notice there's no y in this. And then you can just set it equal to 0 and go through the same steps. So before I can do anything, I need to get these numbers on the same side of the equation. So I want a positive 1 here, which means I'm going to add both of these numbers to the left side. So I have x squared plus 8x plus 36 equals 0. Well, to complete the square, I'm going to have to subtract 36 from both sides. So what I could have done is just move the 8x over and left it equal to negative 36. Because now my step is to complete the square. So I'm going to take 8 divided by 2, which is 4. And then I'm going to take 4 squared, which is 16. So I have x squared plus 8x plus 16, and that's equal to negative 36 plus 16. I cannot forget to add that number. Now I need to write this as a squared expression, as that binomial. So I'm going to use my number right here. So I have x plus 4 squared equals negative 20. And then to complete this, I'm going to add 20 to both sides. So I have x plus 4 squared plus 20, and that's just going to be equal to 0. And that's all I need to do on this one. All right, so that completes the first part of this. Now we're going to convert an equation in standard form to vertex form when a does not equal 1. So I'm going to go through that right now. All right, so we're going to have the equation 2x squared plus 20x minus 11. And so we're going to have the same steps, except we have one extra step thrown in there. All right, and then we're going to have to be careful at one point. So our first step is still going to be to move the c value. Just like before, we still need to move this number over to the other side of the equation. So y plus 11 is equal to 2x squared plus 20x. But I cannot complete this square right now. If we look back to that perfect square trinomial, the one thing about it is this was just an x squared. There was no number in front of it other than 1. So I need to get this to be the same. I need this to be a 1. To do that, I'm going to have to factor out whatever value is right there. So my second step is going to be factor out the a value. The a value is 2. I still have y plus 11 on the left side. The a value is 2. So when I factor that out, I'm left with x squared plus 10x. So that's the new step that's thrown in here. Now the next thing I need to do is complete the square just like normal, but I'm going to complete the square just inside of the parentheses. So step number 3 is complete the square. Inside the parentheses. So if I'm looking just inside of here, I'm only looking at this. To figure out what number I need to add on, I'm going to take the b value, which is 10, divided by 2 to get 5, and then I'm going to square that. So this is 2 times the quantity, x squared plus 10x plus 25. I added 25 to the left side, so I need to do the same to the right, except we need to be very careful because notice the 25 is inside the parentheses that's being multiplied by 2. So that value that we added to the right side is actually 50. It's actually 2 times 25. So if I have 2 times 25 here, I need to add 2 times 25 over here as well. So down here, make a little note to yourself to be careful. So when you add the c value to the y side, make sure to multiply it by the factor. That factor is that a value originally from your equation. So make sure you multiply by that number out front. All right, moving on to step number 4. We are now going through those same steps as before again. So step 4, we're going to once again write this as a squared expression. We're going to get that binomial again. And this is putting it into that vertex form. So I'm going to take the x squared plus 10x plus 25 and write that as x plus, using this number here, x plus 5 squared. Now I have the 2 out front, and then this is equal to y plus 11 plus 50, which is actually y plus 61. And then my last step is to, of course, isolate the y term. So I need to move that 61 to the other side. I'm going to subtract 61 from both sides, so I get y is equal to 2 times the quantity x plus 5 squared minus 61. So this equation right here is the same as this equation here. Notice that the a value is the same. And if you were to graph these, they would be the exact same graph. So let's do a couple more examples of these before you go on and do some on your own. I will go ahead and do this next example with you. If you're feeling kind of confident, then go ahead and pause the video and try it on your own. All right, so this next one, y equals 4x squared plus 4x minus 48. My first step is to add 48 to both sides. That is always my first step. So I have y plus 48 is equal to 4x squared plus 4x. Now my next step, this is the new step, is I need to factor out that a. So on the left I still have y plus 48, and on the right I need to factor out that 4, so I'm left with x squared plus x. Now inside of the parentheses is where I need to complete the square. So I need to take that b value, remember when there's not a number there, it's an understood 1, divide it by 2, which is just 1/2, and then I'm going to square that. So this is 1/4. So on the right side, I have 4 times x squared plus x plus 1/4. And on the left side, I have y plus 48 plus 4 times 1/4. Don't forget that number right there. And I'm going to go through, I'm going to simplify the left side a little bit. This is y plus 48 plus 1. The right side, I'm going to take my parentheses and write it as that squared binomial. So I'm going to use this number right here. So I have 4 times the quantity x plus 1/2 squared. And then I can simplify the left side one more time. Y plus 49 is equal to 4 times the quantity x plus 1/2 squared. And then, of course, that last step is to subtract 49 from both sides. And when I do that, I get y is equal to 4 times the quantity x plus 1/2 squared minus 49. And this is written in that vertex form. All right, go ahead. If you are ready, pause the video again and work through this next problem. So my first step, of course, once again, is to subtract 7 from both sides. So I have y minus 7 is equal to 3x squared plus 9x. Now I'm going to factor out that a value. So y minus 7 on the left, factor out a 3 to get x squared plus 3x. Now I need to complete the square inside of the parentheses. So I'm going to take the b value, which is 3, divided by 2, which is just 3/2. And then I'm going to square it to get 9/4. So I'm going to add 9/4 to the left side inside the parentheses. And on the right side, don't forget about multiplying it by 3. So I'm going to add 3 times 9/4. Now I'm going to simplify the left a little bit. So y minus 7 plus 27 over 4 is equal to 3 times the quantity. I need to write this as a squared expression, as a squared binomial. So I have y plus, I'm using this number here, y plus 3/2 squared. I can simplify the left side one more time. So y minus 1/4. I just did a little bit of this work in my head. If I have negative 7 plus 27/4, I need a common denominator. So I have negative 28 over 4 plus 27 over 4. When I add those together, I get negative 1/4. It is equal to 3 times the quantity x plus 3/2 squared. And then this last and final step is to add 1/4 to both sides. So y is equal to 3 times the quantity x plus 3/2 squared plus 1/4. That is in Vertex form, so I'm done. All right, I just have one more problem left. This is a complete the square problem, so once again, notice that the c value is already on isolated on one side of the equation. So go ahead and go through completing the square, and then just move everything back to the same side of the equation in the end. Pause the video and try this out on your own. Once you're done, play the video to check and make sure that you're thinking through this correctly. So like I had just mentioned, the c value is already over here, so I don't even need to move it. So I can go ahead and move on to the next step, which is to factor out that a value. The a value is 2. So when I factor that out, I'm left with r squared plus 10r, and that's equal to 64. Now I need to complete the square. So I'm going to take the b value, which is 10, divided by 2, which is 5. And then 5 squared is equal to 25. So inside the parentheses, I'm adding 25, which means on the right side, I need to add 2 times 25 because of the original a value. Now I need to write this as a squared expression. So r squared plus 10r plus 25 becomes r plus 5 squared. So I'm using that number there, and I'm multiplying this by 2 still. And then on the right side, I'm just going to simplify this. So I have 64 plus 50. And when I simplify that one more time, I get 2 times the quantity r plus 5 squared is equal to 114. And then I want to go ahead and move this over so that it is still in that correct form. So I'm going to subtract 114 from both sides. And I end up with 2 times the quantity r plus 5 squared minus 114. And since I don't have another variable, that's just going to be equal to 0. All right, that is all for this section. We just are completing the square this whole time and then making sure our final answer is written in Vertex form. Remember, when your a is 1, you just go through those steps like normal. When your a is not 1, you need to factor it out and then make sure when you add the number to both sides of the equation, you make sure to multiply it by that a value. You are good to work on the homework if you have not done so already. And of course, if you have any questions, please come talk to me about it and make sure those questions get answered.